Hello viewers, in today's class we are going to discuss two important definite integrals, right? And here we are not going to solve these two definite integrals using the usual method of substitution, right? So here we'll use the direct result. Now see, in the first problem we have to find the value of the integral from 0 to pi by 2, and the integrand is square root of 10x, right? And in the second integral we have the integral that is from 0 to pi by 2 and 1 over square root of 10x, right? So in the first problem we have the integrand as a square root of 10x, and in the second integral the integrand is the reciprocal of square root of 10x, right? So now if we follow the usual method of evaluating these two integrals, then we can make use of the concept of gamma function to get the values of these two integrals, right? But here we'll make use of the direct result. So now the direct result is if we have the integral that is from 0 to pi by 2, and we have the integrand as 10x raised to n, right? So if we have the definite integral from 0 to pi by 2 and the integrand is 10x raised to n, then the direct value of this integral is pi by 2, that is the upper limit. So we have here pi by 2, and then we'll write sec pi by 2, and we multiply this pi by 2 by n, right, by this exponent that is n. So we see that if we have an integral of this type, that is 0 to pi by 2 10x raised to n dx, then the value of this integral is pi by 2 times secant of pi by 2 times n, right? And remember here the value of n, it lies between minus 1 and 1. So this is an important condition, right? So here n belongs to the interval that is from minus 1 to 1. So with the help of this result, we can now solve these two integrals, right? So in the first integral, we can write 0 to pi by 2, and here we have square root of 10x. So we have 10x raised to half dx, right? Now if we compare this integral with this one, then the value of n is half, right? And obviously half belongs to this interval minus 1 to 1, right? So we can apply this rule. So the value of this integral is pi by 2. Here we'll write pi by 2. Then we have secant of pi by 2 times n. So n is half. So here we have half. So this is pi by 2 and secant of pi by 4, right? And secant of pi by 4 is equal to secant of 45 degrees, so that is equal to square root of 2. So here we have pi by 2 times square root of 2. So the value of this integral is pi by 2 times square root of 2. Now let us see the second integral, right? So this is also an interesting integral. So here we can write this integral as 0 to pi by 2 and 1 over tan x raised to half dx, right? So square root of 10x can be written as 10x raised to half. Now we can rewrite this integral as 0 to pi by 2, and here we have 10x raised to minus half dx, right? So we can take 10x raised to half to the numerator. So now here n is equal to minus half, right? And again minus half, it belongs to this interval minus 1 to 1, right? So now we can apply this rule. So here we have the value of this integral as pi by 2 times secant of pi by 2. Here we have pi by 2 and n is minus half, right? So now we can write it as pi by 2 secant of minus pi by 4, right? And from trigonometry we know that secant of minus theta is equal to positive secant of theta, right? So now this expression can be written as pi by 2 and secant of pi by 4, right? And this is pi by 2 and secant pi by 4 is equal to square root of 2. So the value of this integral is also equal to pi by 2 times square root of 2. So viewers, from this discussion we have seen that the value of this integral is pi by 2 times square root of 2, and the value of this integral is also equal to pi by 2 times square root of 2. Now let us see this third integral, right? So which is the combination of these two integrals. Sometimes we come across with a problem of this kind, that is we have to find the value of this integral, that is from 0 to pi by 2 and square root of 10x plus 1 over square root of 10x. Right. So in this situation, what we do, we write this integral as a sum of two integrals, right? So we can now write 0 to pi by 2 square root of 10x dx plus 0 to pi by 2, and here we have 1 over square root of 10x dx, right? So now we can see that these two integrals are identical with these two integrals, right? And we have just calculated the values of these two integrals using this rule. So the value of this integral is pi by 2 times the square root of 2, and here also we have pi by 2 times the square root of 2, right? So when we add these two quantities, then we'll get 2 times pi by 2 times the square root of 2. So 2 and 2 get cancelled. So now we are left with pi times the square root of 2, right? So the value of this integral is pi times square root of 2.